Today we will discuss about functions and its types. What is a function? Actually, function is a relation. Function is a relation from a non-empty set to non-empty set to a non-empty set. Empty set. Suppose first non-empty set is your A and the second set is set B. So a function is a relation from a non-empty set A to a non-empty set B such that the domain of the function f is A and there are no two distinct order pairs in the function have the same first element. So a function is a relation from a non-empty set A to a non-empty set B such that the domain of the function f is A and there is no two distinct order pairs in the function f have the same first element. Clear? In other words, you can say a relation, that is in general language, in relation f from set A to set B is said to be a function if every element of set A has one and only one image in set B. Clear? I repeat, a relation f from set A to set B is said to be a function if every element of set B has one and only one image in set B. So you can say AB belongs to F, where F is a function, then f of A is equal to B. B is called image of A under the given function and A is called the image of B, right? If there is a function from A to B such that AB belongs to f of A equal to B, B is called the image of A under the given function and A is called the image of B under the same function. Under the same function. This function is also called map or mapping. Clear? Now we will discuss the type of the functions. There are many type of functions. One is types of function. One is identity function. Identity function. What the function says. Identity function is a real valued function where f such that you can write identity function is a real valued function where f such that r to r f of x is equal to x for x belongs to capital R. Here R stands for real because it is a real value function. So identity function is a real value function where f such that R to R, domain is real, range also real, f of x is equal to x. What is your f of x? General, that is your y. So y is equal to f of x and that is equal to x for x belongs to R. This type of function is called identity function. Domain is your R and range is also R. What is the graph? If you plot the graph, then it becomes like this. X-axis, y-axis, origin. See what the graph equation is y is equal to x. Because y equal to f of x is equal to x. So the equation is y is equal to x. How much x you will take, that much of is your y. So if you mark the points, you will get like this. So if you join, then you will get a straight line which passes through the origin. This is the graph of identity function. Next, we will discuss one more function, and that is constant function. Constant function. What is a constant function? Here, constant function is also a real value function. You can say you can define the constant function f such that r to r where y is equal to, that is your f of x, let that is a constant c for x belongs to r. And what is c? C is a constant. Okay, then this type function is called your constant function. That means if you take the value of x, the value of y remains same. That means for every value of x, y is fixed. For example, if y is equal to 3, then there is a table for that x and y. Y equal to 3 means everywhere y is 3 irrespective of the value of x. If you plot the graph of a constant function, then here y is equal to 3. This is your y-axis, x-axis, x dash, sorry, y dash, and this is your x dash. This is your origin. So if you mark the points, then after if you join, then you will get a straight line which is parallel to x-axis. Clear? And you can say y equal to 3. Why? What is your y? Y is generally f of x is equal to 3. It indicates for every value of x, y is 3. Now what is x? X belongs to R, means x is a real number. This is about constant function. Next we will discuss about polynomial function. What is polynomial? Polynomial means it contains many terms in the form of ax square plus bx or ax cube, like this. Okay, so a function f from R to R is a polynomial function of x which belongs to R, then y is equal to f of x is equal to a0 a1x plus dot 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 a2x square a3x cube, like this. Okay, this is an x to the power n. What are a0, a3, a1? These are belongs to real number, means these are real numbers. a0, a1, a2 dot dot an are real numbers. So a polynomial function is f such that R to R, where x belongs to R, y is equal to f of x is equal to a0 plus a1x plus dot dot plus an x to the power n, where a0, a1, a2 dot dot an, these are the real numbers. So one example you can take, f of x is equal to 2x cube plus 3x square plus 5. This is one example of polynomial function. Another example you can say, suppose g of x is equal to x to the power 5 plus root 5 x square plus 3. This is another polynomial. Like this, you have many polynomials. Now, can you say, suppose h of x is equal to x to the power 5 upon 6 plus 2x. Is it a polynomial function? No, it is not a polynomial function. Why? The power should be a whole number. Then only it is a polynomial function. Because we have discussed for polynomials, x to the power must be a whole number. Right? So that's why here h of x is not a polynomial. Clear? Right. Then you can take one example of a polynomial function. Example is f of x is equal to suppose x square. Yes, where f is from R to R, x belongs to R. You can say the function is given f of x equal to x square. What is your f of x? Generally f of x is your y. Now how can you plot the graph of this polynomial function? We have discussed in the lower classes how can you plot the graphs. By taking the value of x, you will find the value of y, like this. Suppose x is your 0, what is your y? 0 square is your 0. If x is 1, y is 1 square is 1. If x is minus 1, y is minus 1 square, that is 1. If it is 2, it is 4, then it is minus 2, then it is also 4. So if you mark these points, what are the points we got? 0, 0, 1, 1, minus 1, 1, 2, 4, minus 2, 4, like this. So if you plot the points, then you will get a graph of parabola whose vertex is at origin, okay, like this. This is 0, and you will get the points like this. X is 0, 1, minus 1, 1, 2, minus 1, minus 2, like this, and you will get the points here. 1, 2, 3, 4, mark the points, you will get the graph of parabola. This is one example of a polynomial. Remember, every polynomial equation never shows a graph of parabola. It varies, or it depends upon the power, highest power, you can say the degree of the polynomial. As the degree of the polynomial is 2 here, so you are getting a parabolic graph, or you can say parabolic curve. You can write f of x is equal to x square. This is one example. Another, we will discuss rational. This is a rational function. First, we will recall about what do you mean by rational. Rational means which can be expressed in the form of p by q form. That means p by q form, and q is not equal to 0. P and q are the co-prime numbers that we have discussed in 10th class. Now, as p by q is a fraction, so you can say the polynomial may be a fraction. That type of polynomial is called your rational function. So you can define the rational function as f of x divided by g of x, where g of x is not equal to 0. And what are f of x, g of x? And f of x, g of x are the polynomials. May f of x become 1? Can you say 1 is a polynomial? Yes, 1 is a polynomial. That is 1 into x to the power 0, which degree is 0. So 1 is also polynomial, right? For example, 1 upon x, is it a rational function? Yes, it is in the form of p by q. P, that is your 1, q is your x, where p is a polynomial, that is 1 dot x to the power 0, right? So a rational function is f of x upon g of x, where g of x is not equal to 0. F of x, g of x are polynomials, and one example is 1 upon x. You can plot the graph of 1 upon x with respect to its table. I am drawing the graph. The graph is like this. Okay, this is your y dash, y, x dash, x dash, x, which is the origin. This is the graph of f of x equal to 1 upon x. You can draw the table, and accordingly you can plot the graph. Now, what is a modulus function? Modulus function, what is? Modulus function. Function f such that R2 are real to real, where f of x is equal to modulus x. Okay, this function is called modulus function, and what is x? Belongs to R. Now you can define f of x is equal to x if x is greater or equal to 0, and is equal to minus x if x is less than 0. So modulus function on x is always positive. That's why modulus function f of x is equal to x if x is greater or equal to 0, and equal to minus x if x is less than 0. Its graph is like this. Y, X, take the table, accordingly we will get the graph. And always the V shape and the vertex is at the origin, right? And it is always in the first and second quadrant if it is y is equal to modulus x. Now what is signum function? Signum function. Signum function, that is, it is also a real valued function, that is also that R to R, where f of x is equal to 1 if x is greater than 0, and 0 if x equal to 0, and minus 1 if x is less than 0. So what is the domain of this function? Domain of the function is a real number, and the range is the set minus 1 to, always you will get 1, 0, minus 1. That's why the domain is R and range is fixed, that is minus 1, 0, 1. Other than these three values, you will not get any value as a range. Now, what is the graph of this signum function? Graph is fixed, this one 1, 0, another is minus 1. Okay, if it is 1, it is 0 and minus 1. This is your x dash, y and y dash. Okay, this is about your signum function. So what is the signum function says? F of x is equal to modulus x by x. F of x is equal to modulus x by x is your signum function. And what is greatest integer function? Greatest integer function is greatest integer function. Here, this is also a real valued function f such that R to R, where f of x is equal to, like this. See, enclosed in a square bracket. Enclosed in a square bracket. That is called your greatest integer function. Its domain is always R. The range is depends upon x. Clear? Now, if modulus x is equal to minus 1, when minus 1 is less or equal to x, less than 0. So greatest integer x is equal to 0 for 0 less or equal to x, less than 1. Like this, is equal to 2. If it is 2 less or equal to x, less than 3, that's so on. So what is the range you are getting? 0, minus 2, like this you will get the range. It is also called a step function. Step function. Why? Because if you plot the graph of greatest integer function with respect to these values, then it becomes one just like its steps. That's why these are called, the greatest integer function is called step function. Like this you will get. This is called your step function. Okay, this is your y, x, y dash, x dash. You can give the number 1, 2, 3, and this is your minus 1, minus 2, like this. Okay, thank you.